Oh dear. Hey guys, and welcome to the Coffee and Coding Podcast, the show where we discuss everything there is to know about app development. I'm your host Rob J, and in today's episode, I speak with cybersecurity expert Jahmel Harris. We talk about pen testing mobile apps, app vulnerabilities and exploits, how to protect your apps against hackers, and much, much more. This is not one to miss. Quick interruption before we get to today's episode. I just wanted to say a huge thank you to all of you listening who've left a rating or a review for the show. It's very much appreciated. And if you like the show and you haven't left a review, pause this episode now, open your podcast app and leave a 5-star review. Or 4, I'll take 4 stars. The more reviews, the more we're surfaced in search results and the more people will find the show. Now about today's episode. This is easily my top 3 episodes I've recorded so far. I've always been interested in cybersecurity, but I never really thought about it in the context of a mobile application. There's the obvious thing, which is, you need to store someone's data on the device. You encrypt that data when you store it. Super simple. I never really looked beyond that kind of scope, but speaking to Jahmel kind of blew my mind a little bit. I don't want to spoil the episode for anybody, so I won't give too much away, but I will say that during this conversation, he talked about one of the more interesting security exploits that he's carried out on a mobile app. So without giving away any spoilers, I'll just drop some keywords. So we're talking a banking application that was trying to implement a Apple Pay, Google Pay type style setup before those were a thing. A credit card that Jahmel and his team created in order to hack this application by sending a payload from this dodgy credit card to the mobile application via the NFC payment system that they'd implemented. That's just a taste of what you're going to be listening to in this episode. And if you like it, feel free to share, because from what I've seen, there's very little information about that involves mobile security specifically aimed at people that build the mobile applications. So this was a fun one. Now on to the show. So the first thing that I'm actually really interested about is, how did you get into cybersecurity? Because from the very little amount of knowledge that I have, in order to get into cybersecurity, you have to essentially be hacking for yourself. So how does that work? How did you get into it?
So, yeah, I really wish there was an answer that was applicable to everyone. And that's kind of one of the things with cybersecurity. As you said, it's one of those fields where you kind of need to be doing it to get into it, which makes it really difficult. I hope one day there's kind of like a defined route, but yeah, for now there isn't. My story is not particularly interesting, to be honest. I think it's kind of the classic story. When I was a kid, I was playing around on computers quite a lot, and it gets to the point where you do start to understand how things work, and for some people they're kind of interested in how to break things with that knowledge. And so that's kind of what I did. I had some friends in school, just learning about computers, teaching each other things. Then, I went to university, did computer science, and actually started working as a software engineer just out of university. And then I got a call from a recruiter, said, "Hey, there's a pen test job." And at that point, pen testing and security testing, ethical hacking was always something I was interested in, but I never really considered it as a job. It was more of a hobby. And then, spoken to the recruiter. He said there's a few companies, interviewed with some. Some of those interviews went really, really badly. I learned kind of what you should and shouldn't kind of say in cybersecurity interviews.
Oh, really? Okay.
Yeah, so I made the mistake of making a joke about. The question was kind of like this, how did you get into cybersecurity? How did you learn this stuff? And I made a joke saying, "Oh, I don't want to incriminate myself," assuming that they would understand that it was a joke and I was just playing. But they took it very, very seriously. But yeah, then started working as a pen tester. That's basically it. So as I said, just learning that I enjoyed playing with computers as a kid, and then finding out one day that people would pay me to do the stuff that I enjoy to do.
Nice. So how long into your career from like pen tester did it take to lead up to? Because now you founded your own company, right?
I have, yeah.
So how long was that process between, getting into cybersecurity to now?
So I first started working in a cybersecurity company, I think around 7 years ago or something. So a few years working as a consultant. kind of building up my skills, understanding how to deal with clients, because that's one of the big things, right? Learning the technical part is significantly easier than learning the client part. Yeah, so I spent a lot of time kind of building up that side of things. Then I started working internally at a company, helping them with pen testing. That was nice because it was a lot slower paced than like consultancy, but it was also kind of boring. You're looking at the same kind of technologies every day. And then I decided that, the next step, I think, in my career, the only thing left really is to start my own company. So that's what I did.
Nice. And that's been 2 years now, right?
That's been 3 years, I think. 2017 we started.
So then I guess going from there, so you're talking about pen testing. So like I said, the only thing I know about cybersecurity is what I read in headlines, and occasionally I'll read about, some software I've got on my computer that I have to uninstall immediately because, it's a huge problem. So in terms of mobile development, I guess the first question is, how much work do you do with mobile development, or how much work is there in your industry in mobile development even?
So there is quite a lot, but it tends to be focused on the kind of the high risk things, which kind of makes sense, right? So, what we don't see a lot of is like mobile games, for example. That's not something we do a lot of testing for, but banking apps, fintech, they're the ones that are really are actually kind of like heavily tested, security tested. There's a big kind of industry around that, and I've done a lot of work with that in the past. With some big banks, and now we're looking at trying to help some of the smaller fintech companies, because the big banks they're in a position where they kind of know what they're doing. I find that the smaller fintech companies are kind of struggling to get some of those kind of advice and knowledge and guidance.
So then what is it that you're looking for before, like not specifically at fintech level, but let's say just, app development level? What is it that you're looking for to test? Like how do you pen test an app essentially? And what are the holes that you're looking for?
So it is different to looking at things like web applications or even infrastructure. When people think of ethical hacking, it is about trying to kind of break into companies and stuff. But the apps themselves are a bit different. I try to think of it from a couple of different perspectives when I'm looking at an app. So I think about what someone can do if they had access to the phone, because obviously the phone itself, it has a PIN or password to keep people protected, but not everyone is going to have that. There's no guarantee that the user has that set. So I look at the application, if someone managed to get hold of the phone, if it was unlocked, or, someone could be coerced into unlocking it, what could an attacker do? The second thing is, what could someone do if they had malware installed on the phone? Right, so there's this big thing that, with malware, sometimes it even gets into the Play Store. What's the kind of worst case scenario there? Because the way that the mobile phones work is, not everything runs as a high privileged root user. So any weaknesses in the application itself could really impact, the user's data and the security of their stuff really. And then the third thing I look at is the data going between the phone and the out to the internet, is that secure? Is someone able to kind of man in the middle of that or view that data as it's going across? So they're the three main perspectives. And then the final one, depending on whether it's in scope, is actually looking at the back end stuff as well. Because obviously the devices do connect to the internet. They connect to a web service. If that's in scope, I look at that web API. But then it becomes more of a web test. Then I guess I should kind of say as well that one area that is kind of heavily looked at is how easily can someone break the client-side controls? Because a lot of these apps, especially with the big banking apps, they put a lot of effort into making these apps hardened, right? So they will use things like certificate pinning, or they will have obfuscation techniques to stop someone from reverse engineering it, or they might have root or jailbreak detection. A big part of what we do is actually trying to see if we can break those security controls, because the idea is that they protect the app so that an attacker can't then start to look for these other things. They can't then go to see how their malware works, or can they access the web API. So sometimes we'll spend a lot of time on that first section first.
Right. So would you say that looking at, I guess we could take banking applications as a good example, because I think everyone would get that the security risk there. Would you say that when you're pen testing an app, are you pen testing it to see if that gives you an avenue into the infrastructure behind it, as opposed to essentially just breaking the app, and if it was a banking app, you could pull out the data from the app. What is that? What we're looking for there?
So it can be both, but as I said, it tends to be whatever makes sense for the client, right? So a large banking company, they're going to be less interested in attacking the infrastructure from the app, right? Because the way that it tends to work, obviously, is you have the one team that is developing the application, another team handles the infrastructure. So the infrastructure team, they will get a pen test on the infrastructure and how that works. The application team will get the pen test on the application. So when we're looking at the app just in isolation, it doesn't really make sense to start looking at the infrastructure, because that's kind of handled by like a different team. So we will look at the app and we'll look for ways that someone might be able to abuse that app. For example, whether they can, take money from people's accounts, or whether they can have, maybe even, as I mentioned, malware before, but, can I install some malware that will kind of interact with the app, pull data out of it? As an attacker, am I able to exploit the application to access the application sandbox, for example? Yeah, but I mean, as you said, it is also important that we do look at the infrastructure as well. And sometimes the two can be, tied together. It really just depends on kind of what makes sense for the customer at the time. So we will work with them to help them understand exactly what it is that they need, so that they can focus on like looking at the parts that are relevant at that time.
The fact that you said banking is interesting, because I've worked with people that have worked for banks, at least previously to IR35. They used to hire a lot of contractors, and they've talked about, they had to build keyboards for banking applications because they were afraid of using third-party keyboards and stuff. So that makes a lot of sense. So then in that situation, what would you say is, and maybe iOS and Android are different, but what would you say is the biggest attack surface that somebody would have in terms of mobile apps?
Well, I think for both iOS and Android, it is pretty similar. And again, it's about this idea, what can someone do in order to learn about the system? So, because the application itself, it is going to be able to make these requests. So it's trying to figure out how those things are happening and what kind of protections are in place. Is it just sending an identifier? Maybe it might take you 6 months to be able to actually look at the network traffic, because there are so many protections on place. But once you do it, can you just change the ID and then, transfer money from other people's accounts? So that tends to be the big thing. It's the kind of the protection of the, either of like the API that the apps connect to, or it's about the data, the security of the data that's running on the device. Is it running is it just containing the user's password, for example? And I do actually have a story about this one. Like, this was on a pen test I did quite a few years back, but it was for another bank, and it was actually a bank that was outside of the UK, and they had a mobile app, and they had this like Bluetooth card reader, right? So the idea was that if you're in a shop, the retailer could have this system to like take card payments and stuff. Like we've seen this quite a lot nowadays, but this was kind of as that kind of thing was starting to become popular.
So this is like an early evolution of Apple Pay or something like that.
Yeah, exactly. So yeah, Bluetooth device, phone over the internet, so someone can make a card payment. And the application was actually written by a third party, right, to the bank. And one of the key requirements that the bank had was to make sure that the username and password was not stored inside the application at any point. And we started to analyze the app. And of course, the username and password was stored within the application sandbox. And I mean, there's a few ways to access it. During our testing, we found that we could, perform like backups of the device, all that stuff to get it. But the coolest kind of exploit that I discovered, though, is we managed to make a fake card that we could scan, and that card had a JavaScript payload. And when we scanned the card, the JavaScript payload was executed on the phone, and the phone was using a web view to display the details. So the JavaScript was executed. The JavaScript was executed within the context of the phone, within the application. So it could read the data from the application sandbox, and then we could exfiltrate that to our servers. So the idea is you walk into a shop with like a fake card, tap it on the device, And then now you've got the banking password of the shop.
That's crazy. Okay.
It was really cool. Like, not many of our tests are kind of as cool as that, I think, but that was one that sticks in my head as being like particularly interesting, just because there were like a number of flaws. As I said, one, the password was stored within the phone. So the question is, how do we access that? And then there was two, okay, so there's a web view in use with JavaScript enabled. And three, that we were able to get JavaScript running within that web view by kind of injecting this data to it, because it was just displaying that and like, yeah, a normal cross-site scripting vulnerability, but in a mobile app.
Yeah, that's crazy. How do you even make a card like that?
We had a few different ways. You can get like NFC devices that will kind of spoof cards and things like that. But the company I worked at the time, I'm actually doing lots and lots of research into that kind of thing. A little bit off topic here, but one of the guys there had this card that he actually found loads of exploits of vulnerabilities inside actual card readers, so ones that you just see in the shop. So, if you're in like, the supermarket or whatever, and where you put your card in, he actually managed to find a load of exploits for those. And so he had his this special debit card that he made that he could put into one of these machines, and then the game would start playing on that device, like this racing car game.
Ah, that's crazy.
Yeah. I know. I remember seeing that when I was like, I just started working there. This one time we went to the shops together, and he paid for his stuff just before me. I was like, I don't really want to pay for my thing in there. I know that he's got this special card. But like it was a cool thing. So the company I worked at, we did a lot of work into card readers and things like that. The other way that you can test this stuff is like, so, and I've done this before, not with a card, but this was another Bluetooth device we were looking at. We want to look at the traffic between the Bluetooth device and the phone. And there's this tool called Frida that I use that lets you hook the application. You can change how it works at runtime. So all I did is I hooked the Bluetooth receive method, and I could just change the data that was coming in. So more like simulating a malicious Bluetooth device. And that's the approach that I tend to use when kind of looking at kind of how the applications communicate with the outside world. If I can hook it, and then I can almost inject my own data in and kind of simulate kind of a malicious Bluetooth device or malicious NFC or something like that.
Your work experience already sounds way better than mine. The coolest thing that happens at my work is, someone shows you a piece of code and they're like, look how clean this is.
Well, I mean, that's kind of cool too. And I will be honest, I miss that in a way. I mentioned that I used to be a software developer, and there's something nice about making things. A lot of my job is breaking stuff. And even saying that, the pen test itself is only really as important as the report. So if the report that I write is no good, then actually the pen test itself was kind of useless. If I can't convey to the user like what the point is of what I'm doing is. So a lot of it is, unfortunately, it sounds kind of cool, but a lot of it is just writing reports, to be honest. There's more to that than I thought there would be at the beginning.
All right, I feel a bit better about my job.
Yeah.
So something else that I wanted to ask you then is, what are some, I suppose, common things that you see that, developers or companies make that are straight away when you start your pen test super obvious this is a problem?
For mobile apps, do you mean specifically?
Yeah.
So the big thing that I saw at the beginning was the idea that a mobile app is different, right? So there's all these vulnerabilities that people are really kind of aware of. So SQL injection, cross-site scripting, all those ones. And then when mobile phones started to be used more and apps became kind of a common thing, it's almost like developers forgot about those because it's a different platform, right? Android apps can still be vulnerable to cross-site scripting because they have a database. We know how to protect against. They can be. I meant to say SQL injection. They can be vulnerable, to SQL injection because they have a database. But it's almost like when people started thinking about it in a different context, started thinking about mobile phones, they just didn't think about it in the same way. Cross-site scripting as well. Web views are in use, so cross-site scripting attacks are still something that is important to think about. And I remember looking at, I do a lot of just kind of, I like to take random apps and try and look for vulnerabilities, assuming that it's within the bounds of law, which it usually is when it's with like either there's a bug bounty or if it's just an offline app. I remember looking at one when I was just getting into kind of mobile testing, and it let you basically you set like a username or something, and it sent it to the server, and then it displayed it on like a board, and everyone on the app could like see each other's messages and stuff like that. And that was runnable to cross-site scripting just because it was a web view, right, that's been loaded. So I could set and I didn't do this because this would have been kind of beyond what was legally allowed, but I could have set a message or username with a JavaScript payload and then started to exploit everyone's phone. And at that time, it was possible to get full command execution on an Android device using just a JavaScript payload. So in theory, anyone that had the app installed, I could have taken over the whole phone. So yeah, a lot of it is just being aware of the stuff that we already try to talk about when we're talking about web applications. And then the other part is just kind of being aware that if someone has your app installed on their phone, they have full control over how that works. So this other pen test I was doing, it was for an application that let people like view video, but you weren't allowed to display that video on like an external device, right? So you couldn't like cast the video. And I think this was because of licensing issues or something like that. And so I was playing around and I noticed that I wasn't allowed, like it said to me, you can't do this. So I used Frida and I hooked the application and I disabled that security control. And then I was able to like play video on external devices, like cast it and things, because you're basically you hook the function and you just make it return like false all the time. And I just kind of did that because I thought it'd be kind of fun and put in the pen test report because I'd have like a picture of me like playing the video on the screen. And I mentioned this to the client almost in passing while I was still doing the rest of the test. And it was a big deal. They're like, what, you can do that? And then I had to talk to all the developers and things. That's something that I wouldn't necessarily as kind of an external person really think about, but it was an important control that they put in place. And so being aware that any security control that's running on the device can be broken, I think that's the other thing that is really important to think about when you're the developer.
Have you heard of, I assume, but I don't want to assume, have you heard of Exposed on Android?
Yeah.
So is Frida kind of that similar?
Very similar thing. So Exposed is actually a tool that I use quite a lot. I prefer Frida because it's a lot quicker to develop. So Frida lets you, with Exposed, you normally have to like reboot the device every time you modify the hook. With Frida, it's just instant. So you can even just, you basically just save the file and then that's the new hook. So it's really good for kind of like doing things rapidly. Exposed is really good for doing things permanently.
So the last time I did anything with Exposed was probably 2014, 15, something like that. At that time, I had an app that was kind of popular. And on the same forum, so I'd posted it on XDA developers and people were leaving comments and stuff. And in that same thread, someone had left a link to an Exposed module that they'd made to basically not have to pay for my app. Which was on the one hand, I was like, all right, well done, you did it, so great. And then on the other hand, I emailed the guy who had created Exposed at the time, and I was like, is there anything I could do about this? And he came back and he was like, yeah, it works like this, you can do this, this, and this. And that was a long time ago. And after about 3 months, they changed things. Suddenly your protections don't work anymore. And I gave up trying to like do this back and forth, because in my mind, there was like, there's no point. It's fine. There's a handful of people that are going to do that regardless. But I haven't looked at that in a long time. So are there any things that you can do now to protect yourself from that kind of thing? Because I think back in the day, also part of it was obfuscation, where if you didn't know what to hook, then it made it a lot harder for you to do those things.
Yeah, so there are a few things you can do, but again, it's all stuff that's running on the device. And so with banking apps especially, I always do kind of recommend that they look at some of these controls so that they can do obfuscation, right? And if obfuscation is done well, it can take a significant amount of effort to try and figure out what it is that you want to hook. The last banking app I looked at, actually, I think it took me a week or so just to kind of figure things out, because they were doing like all strings were encrypted. Like there was all this like code flow obfuscation. Every variable name is basically called A. So you're like package name A, variable A. So it becomes like a real pain. And actually I had to use like more dynamic methods. So I actually had to like attach a debugger to it to try and like follow the flow. I was actually trying to use some things to try and hook the like string methods to try and decrypt them. It was it was horrible.
Which is the intention, right? They want to make it really difficult for someone that they might give up.
Yeah, exactly. But there are other things you can do. You can, for Frida and for Exposed, you can look for the presence of those things. So Frida, when it works, it injects this library into like the shared object into the binary. So if you can look at what objects your application has loaded, if you see the Frida one there, then you kind of error out. The same with exposed. You can see you can detect usually whether like exposed is being used. So if you have that, if you have obfuscation, and if you do the same for root or jailbreak detection, you can start to kind of layer these controls together so that actually, so defeating jailbreak detection is super easy. Defeating jailbreak detection and obfuscation, that's going to be a lot harder, because I can't use my dynamic tools to help me with the obfuscation if I can't run them because they need root. So the two things, they kind of work together. And then of course you add kind of hook detection onto that. And now all of a sudden I can't run it on a rooted device. I can't use exposed. I can't easily obfuscate it. So I can't, disable those controls even once I find them. Eventually, yes, you'll be able to do it, but it'll take a lot of effort. So that's really the kind of the way you try to defeat these things. And to give it some kind of perspective, one of the banks that I was working at, doing some pen testing for, they put a lot of effort into this stuff, as I said, and it took somebody, I think, a full year to be able to interact with the API. Yeah, I think this person, they were trying to make like all-in-one banking app, so they could use like all the different banking things. And yeah, it took them a full year just to be able to interact with the API. And the bank themselves, actually, the API was kind of encrypted on top of normal TLS encryption. They actually had their own encryption on that. So then, so a year to be able to like reverse it enough and change the controls in order to do it. And then you've got to figure out how their API works. We had the custom tools to do that, because we could talk to them and see how they were, like how that works. So we made, have you heard of Burp Suite?
No. So
Burp Suite is a proxy, kind of like Fiddler, if you've ever used that before.
Yeah, I've heard of Fiddler, yeah.
Yeah, so it's kind of like that, but it has the ability you can write your own like plugins and things. So, we were working with the bank to understand how the kind of the encryption and stuff worked, because it was this like, horrible custom like protocol they were using. But then we could write a plugin for Burp Suite to allow us to kind of like view that stuff. But trying to do that all black box, like first being able to actually interact with the API, then interact with that, it would take a significant amount of time. And like, for one, if I'm not being paid for it, I cannot be bothered to put that much effort into just interacting with a banking app.
So that's super interesting. The thing that it keeps coming to me though is the bottom line is, at the end of the day, it can always be beaten, right? Like whatever you put in place, there's not going to be a situation where it's like, this is the thing, it's never going to be beaten. Especially because if you tout it like that, I could imagine, somebody will say today, I've created this thing, it can never be beaten. Tomorrow, somebody's going to beat it.
Yeah, you should never say something is unhackable. People have made that mistake in the past. I don't know if you saw, but I think like last year, what was it called? BitFi, which was this like Bitcoin wallet. They claimed that they were unhackable, and the hacker community just completely destroyed them.
Right? It is a challenge,
yeah. But it's the same for everything, right? So, even like, let's take a company like Google, right? Massive company, massive budget. They're still running servers. The server is going to be vulnerable, like maybe not easily, but if you can spend enough time and effort on it, you'll be able to find some kind of vulnerability. The operating systems themselves, have issues. So I do try to recommend like a layered approach as well. So like a defense in depth. So we can say like, okay, let's assume that this control gets broken. What else is there to do? Because for a lot of companies, it doesn't make sense to try and protect yourself against nation states. I run a security company. If China or Russia wanted to hack me, they could do it, right? Because the amount it would cost me to be protected against those adversaries, I don't have the budget for that. So I need to think about what makes sense, and then try and protect myself from those things. Google probably do need to worry about China hacking them. So they're going to have more like security in place, and they will add these layers. So yeah, that's kind of why I tend to say to people, like, yes, a lot of the controls can be broken, especially when they're client-side controls. But, how much effort do you want to put in? Try and figure that out. Then you can figure out your budget. Then you can figure out like how much dev time, for example, to implement these things. As I said, for some apps, it probably doesn't make sense to add all this stuff. If it's an open source application, for example, like an Android app, don't spend time with obfuscation. What's the point? The source code is available. Spend the time instead to make sure that there's no vulnerabilities in that code.
Yeah, that was the deal with me. I gave up after a bit because I was just like, there's no point. I'm not Google, and I'm not even making a living from this app. So what am I doing?
Exactly.
So I guess another question is, and this would be kind of interesting, is what's kind of the state of mobile OS security right now? Because, you hear year upon year, back in the day, Android was not great. And then, they added SE Linux, and then they added Sandbox in, and all these different things that you hear about. And, when you hear it, it's like, well, obviously now it's impossible for people to do things, and it's obviously not. But how much has it improved over time? And kind of, I guess, like, where are we at now? Is it still... I don't want to say is it still super vulnerable, because the answer is obviously going to be it's not unhackable, but like what's the general state there?
So I think pretty good, to be honest. I mentioned a bit earlier, but speaking about how things were back in the day, there were issues where, as I said, like someone could take over your full device if they can inject some JavaScript into it. And what that realistically meant was that you could take over any device, because like all these applications, even if they weren't making kind of HTTP requests, they usually had adverts in them that were, right? So you have your phone, you connect to a open Wi-Fi network, like hotel or whatever, and there'll be like an advert somewhere on the device that will make an HTTP request. And so you could do a man-in-the-middle attack, add some JavaScript into that, because those adverts are usually just web views. Run the JavaScript, get full control of the device. So that's how things were, right?
Right.
They were pretty bad. The controls that were to try and like keep your application secure as well were not great. So, like things like when you write your Android app, you have the Android manifest. A lot of the things by default now are disabled, whereas in the past, by default, they were all enabled, right? So like all these activities and things were all just enabled, like, exported by default. So you could have malware that would, for example, let's say that you did have a banking app or something that had like you need to enter a PIN code to access it. It was really easy from a low privileged malware to just jump to the like second screen in the process of bypassing the need for the PIN. This is the stuff that the operating system did wrong at the beginning. Nowadays, though, I think they're doing a lot of things right. So both in terms of kind of user experience, but obviously with security as well. So, you at least I'm not aware of any way to be honest, even do a man-in-the-middle attack without a lot of kind of interaction. So with the newer versions of Android, you can't, even if you install a kind of a malicious cert on the device, it's going to be in the user store, and applications by default won't even trust any cert that's in the user store. So, that they have put a lot of effort into making things like significantly difficult to attack. Yeah, it's just, and that makes it harder for me as well as a pen tester, because I need to have special devices set up in special ways. Sometimes I even need to go to like older devices because, they are a bit weaker, so that I can start to analyze the applications and stuff. But yeah, there are a lot of things that they're doing to make things more secure. And yeah, it's never going to be perfect. You're still going to see stories about, a vulnerability in like Bluetooth or something. But, that will be a vulnerability in the chip that is running like used for Bluetooth or in at least somewhere in that stack. And that's going to be something that takes someone a lot of effort to look for. They're going to have to start like performing fuzzing attacks and, spend time to try and do that. Whereas before, it's just a case of, hey, an application is making an HTTP request. Let's, hack the whole phone. So
I would be surprised if there wasn't a bug or there wasn't a vulnerability in Bluetooth, because in general, it's a horrible experience.
Yeah. There was one that came up, I don't know, I think maybe a year ago or something. I've not tried to exploit it myself, but there was a vulnerability that I've heard about that let someone, I think it was actually get like a root shell on an Android phone just by exploiting some of the Bluetooth stuff. So yeah, that kind of stuff will happen, but it's going to be things that are it's going to be things that are harder to exploit, but also probably higher risk, because like all the low hanging fruit really is kind of, disappearing, if not gone. So the stuff that is left is the stuff that's really hard to find. But in order to make it worthwhile, it's going to be the stuff that's like pretty high risk as well.
Makes sense. So would it be accurate? I mean, I'm hoping not, but would it be accurate to say that iOS is more secure than an Android device or not? Because I'm going by headlines and everyone that I work with that's not an Android developer.
So my pragmatic answer to this is that iOS is not more secure if you compare like to like. And by that, what I mean is the big problem with Android is it's so fragmented, right? You buy a phone, you don't know whether it's going to be supported in a year's time. You don't know if you're going to be getting security fixes. Some people are still using even Android 2. There are all these devices out there. So when you say like Android, you have to kind of think of all these together. So from that perspective, yeah, Android is less secure. But if you take the newest version of iOS against the newest version of Android, assuming that they're both all up to date, I would say they're pretty comparable. With a caveat there, in that Android is designed usually to be a bit more available for a power user, right? So for a lot of the devices, you're allowed to root them. Right? You're allowed to get kind of high level privileges. You're allowed to do lots of these things, whereas iOS make that almost impossible. Which again, in terms of me being a pen tester with these devices, I've actually got an iPhone here that's jailbroken. I can never turn that phone off because every time I turn it off, the jailbreak gets lost. So I've got to have it plugged in and powered on always. And then, someone will ask me to do a pen test. I'm like, yeah, okay, I can do it. And I get the device out because you need to you need to jailbreak it. Is such a, I don't know if you've ever tried to jailbreak an iPhone before.
Not since like iPhone 5 or something.
Okay, so it's like unpleasant, and all the tools keep breaking because they're being kind of developed by different people, and these people might get like bored, or Apple would change something, the tool will break, and the person that have time to fix it. So it's a nightmare, and because of that, it can be a bit harder to probe the devices. So I think that's another reason why iOS kind of gets the reputation for being a bit more secure, just because they don't let people do things. So like, again, think about Android. If I wanted to look for a vulnerability in the Bluetooth stack, it'd be easy for me to get root, easy for me to get fuzzing, like in order to look for vulnerabilities. A lot of the code is open source. I can do that stuff, and I can find vulnerabilities a bit easier. iPhone becomes a bit more of a challenge. Yeah, not impossible, just a challenge.
So really a big part of that is because Apple controls the environment, right? Whereas Android, you can install Android on whatever you want, basically.
Exactly, yeah.
There's still like HTC Ones or whatever they are out there running Android. So
and it's a scary thought, right?
Yeah, totally, yeah. So one other thing that I wanted to ask is, so I remember back in the day, I'm talking like 2013, 2014, before WhatsApp was, super duper popular, there was this exploit that was, because WhatsApp was passwordless, your phone number was your username, and your password was your IMEI number hashed, right? So there was a website you could go in and you could put on yours or someone else's phone number and IMEI number, and now you can read the messages, you could send messages from them. And that website was up for a while. Like, I don't know, 6 to 12 months afterwards, it was still there. And then obviously now people are a lot more aware. But are there any, big, potentially in recent memory, exploits that you've heard of, popular apps that people might not be aware of?
Nothing that I can think of that people wouldn't be aware of. As I said, things tend to be a bit different nowadays. I wish I had a cool story like that one, to be honest. Everything that I'm seeing it really is stuff that is kind of like difficult to exploit. I mean, the things I kind of do see sometimes is like, again, if you think about gaming, where somebody will manage to get the name to like the first place on like some leaderboard just because they can change the traffic and things like that. But no, nothing as cool as being able to view people's kind of WhatsApp messages, just like we're going to a website.
Yeah, that's crazy. All right, well, I suppose that's a good thing. So we're going in the right direction. So you mentioned earlier that you are developing a tool for scanning vulnerabilities that can be run on a CI. So do you want to speak a little bit about that and kind of what is it and how does it work and that kind of thing?
Yeah. So this is called Rex. We call it for no reason other than just we kind of like dinosaurs in the office.
Cool, me too.
Yeah, cool. And yeah, like as I said, I've been doing pen testing for a while, and I tend to focus on mobile applications. And one thing that I noticed, so security itself, I think, has this issue where, we are very much like we do things manually, like we're manual testers. And when I was starting Digital Interruption, my company, I went to a few like QA testing events just because I had this opinion at the time that there was like a hierarchy, right? That was pen tester at the top, of course, then developer, and then QA tester. Which is funny because you speak to the developer, they say that they're at the top. You speak to the QA tester, they say they're at the top. But I had this in my head, and I don't like to just have these kind of like unfounded opinions. So I went to a couple of these QA testing events, and what I realized is they are miles ahead of security when it comes to ways to do testing, right? They like the automation that they're doing is amazing. Like they were demonstrating these custom tools they were writing to run these test cases. And it kind of opened my mind. I thought, why are we still doing it like so manually in security? And I kind of do remember, I was talking to some like when I worked at a previous company doing in-house security with them. I was trying to help some of the teams there. I was like, oh yeah, just try and run some of these security tools and give me the results. And it was like a hard thing to do. Like the security tools are really kind of antique in a way, like all these weird command line interfaces. It's like just not intuitive. They don't fit into kind of any kind of workflow except the pen tester's workflow. So going to some of these events and seeing how advanced like they were when it comes to like ways to test, I started thinking, okay, well, actually, we can improve this in security. So we are writing this vulnerability scanner. And the idea is, rather than just being some weird command line interface that no one knows how to use, it's going to have, it has a web application front end. So if you want, you can just upload the APK. It will do the scan. It will give you the results. But more importantly, it actually has a Jenkins plugin. So you can plug that into your build pipeline. You get in that visibility every single time you're doing a build, which again, that's another weakness with pen testing as it is. Pen test is a single point in time. When you do a pen test, you have no idea whether, you fix a vulnerability. Is it being reintroduced? Is it going to be there like next year? You just have no idea. Like, what the issues are right now. Whereas this, the idea is that, you're getting that visibility every single time you do your scan. So when you start to fix vulnerabilities, you start to know that they're fixed. It's going to check them every single time you know that it's no longer there. And also, we also have an API for it as well. So even if you have whatever software you're using for CI, then you can fairly easily just write like a wrapper to like submit jobs and get results and stuff. That's version 1. That is actually almost released. It is a SaaS tool that we're hosting, but the idea is we want it to be like so cheap that companies, will just use it because, they are getting some kind of like benefit from it. And we'll be looking at like free options in the future as well, like maybe for like open source tools or maybe for like a certain number of scans. We're still kind of like thinking about that. But the first version is kind of already out there. We actually got a grant from Innovate UK to help us develop that. So with that grant, we're going to be looking at version 2. And version 2 of the app, we actually want to be able to allow people to make their own test cases. So version 1, is just a vulnerability scanner. It will look for the issues that we've already told it about. With version 2, we want people to have to make their own test cases really, really easily. So the idea is, maybe you do get a pen test, but you want to be able to turn those into like test cases that will automatically be run with recs. Maybe even as a company, you start to build up a repository of all these test cases based on, you get a pen test report for one app. Well, actually, we can take those test cases and apply it to the other app. So that's kind of where we want to get to, and that's what we'll be working on over the next few months. So, but we do have licenses for people if they do want to kind of get involved and help shape it, see how, give us some feedback would be awesome. So even if any of your listeners or even yourself, if that sounds like something that would be useful, let me know and I'll get someone to reach out and get some licenses over.
Yeah, perfect. Is there somewhere people could go now to have a look?
No, unfortunately. I think we've got some information on our website, but we're really just kind of getting that all together. The scanner is at recs.digitalinterruption.com, but you need a login at the moment, and as we do testing, we'll be creating accounts for people. So the best thing to do is email me at Jahmel@digitalinterruption.com.
Yeah, I'll throw you in the email in the show notes. No worries.
Or if anyone can reach out on like LinkedIn or Twitter or whatever. I'm fairly easy to find, to be honest.
Yeah, I found you on Twitter. So
yeah, okay, cool.
Yeah, quick question about that. So in terms of vulnerabilities, is it a pre-made suite of tests that it runs, or do you write your own? Like, how does that work? What is it scanning for?
So at the moment, it's a preset, list of funds, and we use kind of two different methods. We use SAST and DAST. So SAST, you give it the application, it will like decompile it basically, and it will look for patterns and it will look for security weaknesses that way. And the other way, DAST is dynamic, so dynamic application security testing. So it runs an emulator, throws the application on there, like executes it, and then we do some analysis that way. So at the moment, that's kind of what it's doing, and it's only looking for our predefined vulnerabilities. Whereas, as I said, version 2, that is really where we're going to start pushing the idea that people can create their own kind of test cases and plug that in. We want to have a really slick interface for it as well. Again, like no more horrible command line things. But we either want to have some kind of language that people can write the test cases, or even better, like a GUI. I think I'd love to have a GUI where you can just kind of drag like things together and then you create your test case that way. So that's what we're looking at next. And as I said, that's what we're using the Innovate UK funding for.
Yeah, that sounds awesome. Like, I've worked at a bunch of companies that have no idea about security at all. And just even like version 1, having that in your pipeline is way more than anybody else that I've worked with does. So,
oh, cool. And I would even say for some companies, like obviously I'm a pen tester. I'm going to say everyone should get a pen test. Come to me, get a pen test. But the reality is a lot of companies, they might be okay with just having the vulnerability scan. If it's a very low risk application, or if it's an internal application or something, you know what? Get the vulnerability scan. It'll cost like a tenner. You get the results, you fix it up, and then you're happy with it. The high risk stuff, maybe you still do want to get the kind of the manual pen test. But for a lot of companies, I would much rather them just do a scan, fix up the low hanging fruit, and then release that rather than do nothing.
Yeah, 100%. So last 2 questions that I ask everybody. The first one, and it counts because you did do software engineering before this, is what do you think separates a okay developer from a great developer?
I think willingness to listen and to learn, to be honest. The best developers I've worked with, maybe not even the technically best, but develop the best products, are the ones that, will take my feedback as a pen tester, who will, less ego. I think that tends to be what I've seen, to be honest.
I felt like it might go in the direction of communication.
Communication is super important.
Yeah. That's interesting though, because sometimes the quote unquote best developers are not the best developers. You can't work with them because they don't know how to communicate. So
exactly. Yeah. I had this one dude I used to work with when I was a software engineer, a young guy, but he just wanted to change everything all the time because he was so technical. It's like, oh yeah, we should just do it this way. And in his mind, he's like rewriting everything. We're like, okay, but the rest of the team can't do that. Nor does it make sense, because we're just going to end up the same place we are now.
Totally. That's like when people at companies that I worked for start talking to me about, log in and stuff like that. I was like, I don't know any of that stuff. Like, tell me what you're trying to say in English and I'll tell you how to do it. So last question, what machine do you use to work from?
I have a few, to be honest. For my normal day-to-day stuff, I have a Huawei running Windows. So that's like 2 big crosses for security right there. Yeah. But it's a nice laptop, and as I said, I'm doing lots of businessy things. So having the ability to just easily work with other people is kind of trumps everything. I also have a Linux laptop, and I use that. It's a Dell XPS. I use that for personal things, and also for when I need to use Linux. I do prefer to Linux. I've been using Linux for maybe 15 years, and I think it's a better OS. But saying that, now that there's the Windows subsystem for Linux stuff on Windows, it makes it a bit easier to use that stuff as well. I've also got a Mac floating around somewhere. I basically got at least one of everything, because eventually I'll need it on a pen test.
Yeah, gotcha. That makes sense. You've got a bunch of different machines. Is the Huawei the MateBook?
Yeah, MateBook Pro. Yeah.
All right, nice. Yeah, I've seen those about. Cool. So then I guess the last thing is, where can I direct people? Where can people find you? Where can people find your company? All that good stuff.
So website is good, digitalinterruption.com.
Yep.
I'm on Twitter at jharris_sec. I run a group in Manchester called Manchester Grey Hats, Manchester, UK, obviously, where we run, well, before COVID anyway, we run like lots of free workshops for people, teaching them how to hack websites, how to hack mobile devices, how to use Frida, how to hack radio things. I love like SDR, so like hacking radio waves, teach all this stuff, and all for free, and just because I like it and I like teaching people stuff. So Manchester Grey Hats, we have a Slack, we have Twitter as well, so people can find me on those places.
Big thanks to today's guest, Jahmel Harris. You can find him on LinkedIn, on Twitter at jharris_sec. You can find his cybersecurity company at digitalinterruption.com. And if you're interested in using Rex, send an email to rex@digitalinterruption.com. As always, you can find everything we talked about in this episode in the show notes. If you like the show, tell a friend, and don't forget to subscribe and leave us a 5-star rating. It's much appreciated. And if you really like the show, you can support it with a coffee donation at coffeeandcodingpod.com/buymecoffee. Caffeine is literally what fuels this podcast. If you'd like to connect with like-minded developers, you can do so in our Facebook community. And finally, you can follow me on your favorite social media platform at lowcarbrob. You can find all the links to everything I've just said in the show notes or at coffeeandcodingpod.com. Thank you for listening, and I'll catch you on the next episode of the Coffee and Coding Podcast.